Hello, everybody, and welcome back to Unit 2 of Regents Chemistry, which is Atomic Concepts. Today, we will build on our discussion from last time on electron configuration. We'll talk about ions, and we'll see how we can write electron configuration for ions. So ions are basically just charged particles. They are not an atom anymore, and they're not neutral anymore because their number of protons and neutrons are not equal. Because the reason why they are getting a charge is because they're either gaining or losing an electron, or more than one electrons. So we can remember we can never ever change the number of protons if we are looking at the same element. But the number of electrons can be changed. So an atom can either gain or it can lose electrons, and that's when it becomes an ion. So why do atoms do that? Like, why do they want to become an ion, or why would they want to lose or gain an electron? Because there's this concept called the octet rule, which means if an atom has 8 electrons in its outermost shell, whatever that outermost shell is, it could be its second shell, third shell, whatever the outermost shell is. If that outermost shell has 8 electrons, then that atom would be stable. um, that's what we call the octet rule. So all atoms out there do want to have that. Like, they want to have 8 electrons in their outermost shell and be stable. So in order to do that, um, sometimes they either gain or lose electrons, and that's when they, for the most part, also react with other ions out there. But let's not get into that. We'll get into that discussion in another chapter. So for now, just know that the reason why atoms gain or lose electrons is because they want to have a complete octet. They want to have 8 electrons in their outermost shell, in their valence shell. So let's look at an example of a sodium atom. The ground configuration for a sodium atom is 281 because it has 11 electrons and 11 protons. The atomic number is 11. That's what tells us that it has 11 electrons. So the third shell is incomplete because it only has 1 electron. Now, in order to become stable, nitrogen is going to go ahead and lose that 1 electron because it can, remember, sodium has two options. It can either lose that 1 electron, or it can gain 7 electrons from anywhere else to have 8 electrons in its outermost shell. So whichever way is easier for the atom, that's what they'll do, and the lower number is always easier. So sodium would rather prefer to lose its 1 electron, and then just have 8 in the outermost shell, because in that case, the second shell is going to be its outermost shell. So the new configuration will now be 2, 8. It's only going to have 2 orbits. The second orbit is now the valence orbit, and it's going to have 8 electrons. And the charge on sodium is now going to be +1, and that is because sodium is losing 1 electron. It is losing a negative charge. So these type of ions, the positive ions, are called cations. Okay? Now, let's look at a reverse scenario. Let's talk about chlorine, Cl. When you look at chlorine in the periodic table, the ground configuration is 287. This is the configuration that we find in the periodic table because it has 17 protons, 17 electrons. Now, the third energy level, or the third orbit, is incomplete because it has 7 electrons. So now chlorine has two options. Option number one, it can lose 7 and have 8 in the outermost, or it can just very simply gain 1 from somewhere and have 8 in the outermost shell. So chlorine is going to do whatever is easier, the smaller number. It's going to go ahead and gain 1 electron. When it does that, its new configuration is going to be 288. And now because chlorine is gaining a negative charge, it's gaining 1 electron, the charge of chlorine is going to be -1. Okay, it's gaining 1 negative charge. This type of ion is called an anion. And the easier way to remember this, to differentiate between anions and cations, is that anion basically just means a negative ion. Okay, so that's anion. And then the other one, cation, would then be positive. So let's quickly practice that. When we look at magnesium, make sure that you guys have your reference table packets open in front of you. Open up to page 9 where we have the periodic tables and find magnesium in your periodic table. The electron configuration for magnesium, the ground state configuration, is 282. Now, when magnesium makes an ion, it is going to lose those 2 electrons because that is what's easier for magnesium, to lose those 2 electrons. And the new configuration is going to be 28. When we look at sulfur, it's 286. Now, sulfur has 6 valence electrons, which means 6 electrons in the outermost shell. It can either lose those 6 or gain 2. So the easier path for sulfur is gain 2 and become 288. Nitrogen, the ground state configuration, the one that we see in the periodic table, is 25. Nitrogen has 2 options. Option number 1, it can either just lose 5 or it can gain 3. So nitrogen is going to gain 3 and become 28. Finally, we have argon. The ground state configuration is 288. Now, if you guys notice, the valence electrons in argon is already 8. It has 8 electrons in the outermost shell. So it doesn't need to be stable. It is already stable. And we'll talk more about why argon is stable and where is it specifically found in the periodic table, more about when we are in the periodic table chapter. But for now, just know that since argon is already stable, it will not form an ion. Okay? Only the atoms that are not stable are going to make an ion. And there you go. That was it for this part of the chapter. We have one more thing to cover regarding electron configuration that we'll talk about next time. Until then, take care. I'll see you guys next time.